So if you look here again, I told you I am not going to do the visual representation of the derivative, but if you look at here, they have the original graph from the previous problem we discussed of f of x equals 1/3 x cubed minus x. This is what the graph looks like. Then they find the derivative of it, which is x squared minus 1. They graph it perfectly below it, and they say, okay, because it's decreasing, the first derivative is decreasing on the interval negative infinity to 0. That is where it's concave down. Notice that it is part of a frown right here. So that's concave down, right? And then they notice from 0 to infinity, my derivative is increasing. Because my derivative is increasing, my original graph is concave up. So this is our, let me use the highlighter. This would be the intervals of concave up. Notice that's the part of the smiley face, okay? So all they're doing is looking at the graph to say the derivative is decreasing and the derivative is increasing. That ties directly to the definition of concavity. But again, all we're going to do is use the second derivative. So look at theorem 4.7. It says, let f be a function whose derivative exists on an open interval. If f double prime of x is greater than 0, in other words, if your second derivative, let's go ahead and make a chart here. We made this on the previous page, but I'll make it again. So it says, look at the second derivative. If the second derivative is positive, greater than 0, then it is concave up. And if the second derivative is negative, which is less than 0, says right here, then it is concave down. Okay. All right. And then it says, there's a proof in the appendix if you want to see it. It says a third case of the theorem could be that if f double prime of x equals 0 for all x, then f is linear. It says, however, that concavity is not defined for a line. In other words, a straight line is neither concave up nor concave down. So if you think about a line, it's straight, it's flat, its slope is consistent, right? So the second derivative would be 0 everywhere because the slope is not changing. The rate of change of the rate of change would be 0, okay? It's neither part of a smiley or a frown, and so it's linear, so it doesn't have concavity. That's all they're saying. It's not a smile, it's not a frown, so it's neither concave up nor concave down. It says to apply theorem 4.7, locate the x values for which f double prime of x equals 0 or double 0, or f double prime of x does not exist. So that's our first part, is find the x values. The x values for which f double prime of x equals 0. Use these values to determine the intervals. That was the second part. Test the sign at each of those intervals. That's the third part. And notice when you test it, you're plugging it into f double prime of x. So all this is saying to do is use the sign chart method. On f double prime of x, on the second derivative. That's all that's saying to do right there.